So here it is, February 5th, 2021, here in Alabama. It's a beautiful midwinter day. The sun is shining. It's in the mid 50s Fahrenheit. It's just beautiful. But next week, it is gonna get wicked cold across the continental United States. Every state is supposed to have freezing or sub-freezing temperatures. Even here in southern warm Alabama, we're still gonna have temperatures that are dipping down into the low to mid 20s. And it's all because of, dun dun dun, the polar vortex. What's the polar vortex and why does it make us so cold? That is what this video is trying to try to explain. How y'all doing? I'm Gregg Thompson. I want to thank y'all very much for watching my videos and checking these things out. I would encourage you, go ahead and share this link, the link of my YouTube channel, Science 252, with others that you know, homeschoolers or other individuals. I appreciate all the support that you're giving me. Don't forget to like and subscribe to this channel. And if you have a request for other videos, let me know and I will try to get them on as soon as I can. What the polar vortex is, well, I guess to explain it more simply, I need to show you. So, I brought along my globe. I stole it from my homeschool room. Don't tell the students. I brought along my globe. So here we go. Here's the Earth, okay? Here's the equator. You have the North Pole up here. You have the South Pole down here, okay? South Pole's on that side. Polar vortex is this. As the sun is striking the Earth, okay? Let's imagine it's springtime and the sun's going to strike the Earth right here on the equator. What happens on the equator is that right there, the temperature is going to heat up where the sunlight is most direct, and it's going to warm up this area so that the air here above the equator rises. That produces what's called the equatorial low pressure, equatorial low. This air is going to heat up and rise. Now, in a perfect situation, that warm rising air would hit the upper parts of the atmosphere, the upper parts of the troposphere in particular, and it would cycle around as it cools down, as it lifts, it cools down, and it would travel up here to the poles, and it would sink and become what's called the polar high. But because it's not a perfect system, we have land masses and ocean bodies, the Earth's on a tilt, and so all the heating is completely unequal. It actually does something a little different. Instead of just rising here and going to the North Pole and sinking, it actually rises right at the equator, and then it sinks right about this latitude right in here. And then once it hits the ground, once it sinks again, cools off and sinks, it spreads out along the ground, and as it spreads north, it rises again somewhere up here, kind of in northern Canada and that area. It rises again, and then it spreads out, because as it's moving along the Earth, it's getting warm, it's soaking up heat from the Earth, and it's going to rise again up here, and then it spreads out again, and this time when it spreads out, then it comes down on the polar on the North Pole. Same thing, by the way, is happening in the South Pole. We'll talk about that in a minute. So we have a rising and then a cooling as the air settles back down, and then another rising and then another cooling as it settles in up here. And this is a global pattern. This happens all across the globe everywhere. Well, because of that rising, sinking pattern that occurs, what happens up here right around where the air rises is we end up developing this counterclockwise rotation of air, this counterclockwise spiraling of air around the North Pole. That is the polar vortex. And it's always there. It's there in the summertime, it's there in the wintertime. If you need help visualizing what I'm talking about, imagine a hurricane. Hurricanes have counterclockwise rotation of wind, but in the center of the hurricane, there's the eye. That's that point of high pressure. As that wind circles around, it builds that cloud wall, and then the high pressure gets sucked down in the middle, creating the clear skies, calm conditions that we call the eye of the storm. In a sense, the same thing is happening in the North Pole, only on a much, much grander scale. You've got this high level rotation of winds, and in a sense, as those circle around, it helps to draw that cold air down onto the surface, creating the polar high. In the summertime, it does not affect us here in the northern hemisphere. It doesn't change our weather dramatically because there's so much heating going on here in the northern or in the United States, because it's summertime. There's so much heating here that warm air pushes against that polar vortex and really prevents it from moving. So it stays up here around the Arctic. Same thing is happening over in Russia in the summertime. Northern hemisphere summertime, same thing is happening. Keeps that the polar vortex up here and around the Arctic. But in the winter, when there's not as much heating and we're colder, then there's not as much force pushing against that polar vortex, and that polar vortex begins to slide south. And as it slides south, it affects the jet stream, which is also circling around. It affects the jet stream, causing the jet stream to dip down into the United States and back up. And that dipping down to the United States, that is where that cold air from the Arctic can spill into. So if you were to look at the jet stream path across the United States, if it dips down and comes back up, you can bet that anywhere in that dip, anywhere inside of that, it's going to be really, really cold air. And that's what's happening next week. Now, this polar vortex and the jet stream, these are high altitude winds. They are not down here on the surface of the ground. They're way the heck up there. The jet stream itself is like 5 to 9 miles above the surface of the Earth. So it's way up there. So it's not the vortex itself that is causing the cold. The vortex is forcing the jet stream down, which then sucks the cold surface area kind of underneath it down along with it. And that's kind of the pattern that we find. And that's what's going on literally next week here in the United States. Again, today is February 5th, 2021. Next week, we're having all those cold temperatures because of that situation. Now, a couple of things that people don't understand about the polar vortex. Number one is that, and I mentioned this a second ago, it doesn't just happen in winter. It happens all the time. There's always that polar vortex, but it's in the wintertime when there's not as much, when the warmer air is just weaker and it can't hold that vortex in place. That's when it sinks down. A lot of people believe that it's because of the warming cycle that the Earth is in at this point. Because we're in a warming cycle, we're trending up in our global temperatures. Because of that, there's just not enough heating to hold that in place, and so that's going to creep down and give us these really, really cold temperatures. That's why we're hearing about it more and more and more right now. The other thing, again, I mentioned a second ago, is that these are not surface winds. So it's not like the polar vortex is going to bring us all this insane wind. That's not necessarily going to be the case. It's only going to bring us the winds that come as a front might move through, as fronts tend to follow the jet stream. I'll do a video on that at some point, and we'll get to that. And here's a little tidbit that you might not be aware of. There is a vortex, not just up here, a polar vortex, but there's a vortex that occurs down here in the southern hemisphere as well, around the continent of Antarctica. Now this vortex, in the summertime, it's the same thing. In the summertime in the southern hemisphere, which would be wintertime for us, it is actually it's contained by the heating that's occurring down in the south. It's more contained, just like it is up north. But in their winter time, which is the northern hemisphere's summertime, in their winter time, it also weakens and begins to spread. Now, it tends to contain itself a little bit more. See, there's the wet LC. A little bit more right over here. There it is, the Ross Sea, along the Ross's ice shelf. It continues to hang out around those areas. Is where it seems to be concentrated. We really don't hear a lot about it in the news, simply because if you look around the southern hemisphere, if you look, there's really not a whole lot of people. There's not a whole lot of population or land masses around this area. Perhaps it could affect the southern tip of South America a little bit. It might be what causes all those crazy wicked storms here in the South Atlantic. It could be the cause of those things. Perhaps even affecting New Zealand or Australia to a certain extent. We just don't hear about it because the population of this area of the world compared to this area of the world is much, much smaller. Because it doesn't impact people as much, well, you know, we measure all things based on how it affects us. That's the kind of the human condition. So there is one that happens in the southern hemisphere. It's just not nearly as advertised as the one that happens up here. And that is the polar vortex, why or what it is and why it affects the weather the way it does here in the United States.